Good morning, everyone. I hope you have been okay. So, today we're going to study about the Earth and the solar system. But before we get to our daily class, before we start our lesson, I would like us to pray. Okay, so let's close our eyes for a word of prayer. Dear Heavenly Father, we come before you this time of day. We thank you for being with us. Dear Lord, may you bless us and be with us. And God, that every lesson, everything we're going to be taught, everything the learner, I will teach the learners, God. I pray, God, that you may open their minds to understand. In Jesus' name, amen. Okay, so let's begin. So, what did we study on our last class? Remember, on our last class, we talked about the introduction to geography. We said that geography is the study of the earth as a home of man. We looked at the branches of geography. We looked at the physical geography, the human geography, and we looked at the practical aspects of geography. And then we looked at the relation between the geography and other subjects. We said that geography is very much related to mathematics because it uses the mathematics equation formulas to calculate different statistics in geography. And then we looked at other subjects also related to geography. We saw that it is related to economics, it is related to history, biology, and all that. And then we also looked at the importance of geography, one of it being it is a career subject. And then we looked at other importances of studying geography. Okay, so today we're going to look at the earth and the solar system. The earth is where the human beings live, and then we're going to look at its properties, its structure, its components, as well as that of the solar system. Let's begin. The solar system consists of the sun and the 9 planets orbiting around it. We all know of the 9 planets, or if you don't know, do not worry, because I will take you through of 9 major planets, which include Mercury, which is closest to the sun. We have Venus, we have Earth, we have Mars, we have Jupiter, we have Saturn, we have Uranus, we have Neptune, and we have Pluto. So these are basically the 9 planets of the Earth, of the solar system. So we can consider other heavenly bodies of the Earth. We can name the other heavenly bodies of the Earth, which include the asteroids, we have the comets, we have the meteorites, we have satellites like the moon, and we have the meteors. And then, having seen what the solar system is and the components of the solar system, and also the other heavenly bodies that we have looked at, we can go ahead and look at the theories supporting the Earth. What are the theories supporting the origin of the sun and the solar system? So we have 2 major theories that explain, or rather describe, the origin of the Earth system. The first one is the passing star theory, and the second one is the nebula cloud theory. So we're going to look at each and every one of these, their descriptions, and then we're going to look at the limitations of each. So let's begin with the passing star theory. So the passing star theory was stated by 2 brothers who are Jean and Jeffries. So the Earth is believed to have been formed 4.6 million years ago. So let's describe the passing star theory. So, star theory states that there was a star which had a greater gravitational pull than the sun, which passed close to the sun and pulled materials from the sun, scattering it in various directions. The materials later then cooled and condensed to form the present day solar system. Okay, so by looking at that, we have seen how this materials, the planets, are formed, why they are circulating in an orbit. This is because, again, we have said that a star with a greater gravitational pull passed close to the sun and pulled materials from the sun. These materials from the sun then was scattered in various directions, and then after being scattered in those various directions, they cooled and condensed to form these 9 planets, or rather the present solar system. And then from there, we're going to look at the limitations of the passing star theory, because scientists came to see that maybe that's not the case. Maybe there's something else that happened. And then, having looked at those 3, we have said that chances of another star approaching the sun are very minimal. Number 2, we have said that the theory does not explain where the sun and the star came from. And then the third thing is that these high temperature materials that were pulled or rather drawn from the sun would have dispersed rather than condensed. Are we together? I hope we're together up to there. And then we're going to look at the nebula cloud theory. So, what is the nebula cloud theory, and we're going to describe it, okay? So, it states that there was a whirling mass of hot gases and dust which later became the sun. Small particles broke from the sun and continued to rotate in an orbit and later cooled and condensed to form the present solar system. Okay. We're going to look at other components of the solar system. We have the sun. So let me teach you a little bit about the sun. So the sun is made up of very hot gases and it produces its own light. So the temperatures in the sun are very high, of up to 6,000 degrees Celsius. That is a very high temperature. And then the sun is a unique star because no other star known to man has heavenly bodies around it. So it is a unique star. Another thing, it rotates on its own axis in an anti-clockwise direction. Okay, so we have looked at 4 properties of the sun. We've said it is made up of very hot gases and it produces its own light. These very hot gases are of high temperatures of up to 6,000 degrees Celsius. We've also seen that the sun is a unique star because there is no other star that has heavenly bodies surrounding it. And then we have also said that the sun rotates in an anti-clockwise direction. Okay, so after looking at all that, after seeing the sun, we are going to look at the moon. Say the moon is a natural satellite. It receives light from the sun and reflects it to the earth. And it mainly occurs at night. Mainly. And then we're going to say that we have planets. Planets are other components of the heavenly bodies or of the solar system. So let's look at other properties of planet Earth. We've seen that its circumference is estimated to be 40,000 kilometers. The equatorial diameter is estimated to be 12,762 kilometers. And then the polar diameter is 12,722 kilometers. The equatorial circumference is 40,085 kilometers. The polar circumference is 39,955 kilometers. A surface area is 510.1 times 10 power 6 kilometers squared. And then lastly, we're going to say that 75% of the earth is covered with water. And what about this other 25%? The 25% now is where we live, the continental part. This is where you and I reside on and the human activities take place, okay? So that is the continental part, and then the 70% is the oceanic part, where it is covered by water. So looking at all that, we're going to move ahead and look at the shape of the earth. So some people have been saying that the shape of the earth is circle or spherical. That is not true. The shape of the earth is actually oblate, spheroid, or let's say geoid in shape. Why? Because it is flattened at the poles and bulges at the equator. Okay? It is flattened at the pole and bulges out at the equator, so it forms something like this. It is not specifically spherical. It has a shape which is now called the geoid or oblate spheroid. Okay, so there are three forces that I am going to talk about which are responsible for the shape of the earth. The forces which are responsible for the flattening of the poles are called the centripetal force, and the forces that are responsible for the bulging of the equator are called the centrifugal forces. And then we have another force that pulls everything to the center of the earth. What is the name of this force? From other sources, or if you've heard from other places, you can be able to tell that it is actually the gravitational force. Okay. Yes, so we have looked at three forces: the centripetal force, the centrifugal force, and the gravitational force. The centripetal force, which is responsible for the flattening of the poles, the centrifugal, which is responsible for the bulging of the equator, and the gravitational force, which is responsible for, or rather we can say it pulls things to the center of the earth. Okay, points that prove that the earth is spherical. Number 1, circumnavigation. Number 2, observation of the ship. Number 3, the sun appears earlier to the east than to the west. Another thing, the photographs taken by the satellite actually are spherical. When you look at those photographs, you'll see that they are spherical. And then the last thing we said, since all planets and heavenly bodies are spherical, the earth is also spherical. We have seen, or rather, when you look at the different planets of the earth, you can see that their shape are actually spherical. The earth being one of it is also spherical. Okay. Another thing we're going to look at is movement of the earth. So the earth moves in two different ways: rotation and revolution. Okay. So we have rotation and revolution. We are going to look at the definition of each and then the description of it, and then we're going to look at the causes of each or the effects of each. Okay, so the first one, let's talk about revolution. Or no, let's start with rotation. It is much easier so that you get to understand revolution. So what is rotation? Rotation is the movement of the earth around its own axis, or rather, it's the spinning of the earth on its own axis. Okay, so rotation has different causes, or causes of rotation include it causes day and night. Okay, it causes the changes or the effects in the direction of wind. It causes the changes in the direction of wind. Okay, and then it also forms the equatorial bulge, and it affects the force of gravity. Okay, so it affects the force of gravity. It causes changes in day and night. It causes changes on the direction of wind and ocean currents, and then it forms the equatorial bulge. Okay, so that is basically about rotation. Now let's look at revolution. What is revolution? Revolution is the motion of the earth around the sun as it follows an elliptical path. Okay, what are the causes of revolution of the earth? It causes the changes of the 4 seasons. The 4 seasons include the autumn, spring, the winter, and summer. Okay, summer, autumn, spring, and winter. Okay, we're going to look about each of that in details, but first we're going to look at the causes. So said it causes the 4 seasons, and then it causes the variations of day and night, or it causes the change of length of day and night during the year. Okay, and then it changes of the position of the sun. It changes in the position of the midday sun, okay, and night during the year in the different parts of the earth. Okay, it changes the the position of the midday sun at different times of the year around the earth. Okay, the last part is it changes or it causes changes of the lunar eclipse. We have the solar eclipse and the lunar eclipse, but here revolution causes the changes of the lunar eclipse. Okay, yes, so after we have talked about the movements of the earth, we are going to look at the longitudes and latitudes of the earth. So what are latitudes? Latitudes are the imaginary lines drawn from east to west. Okay, so imaginary lines running from east to west are called latitudes, or rather we can say that they are parallel. Okay, so the latitude is located between the northern hemisphere and the southern hemisphere. Sorry, and then the longitudes are imaginary lines drawn or running from north to south, and it is located between the eastern hemisphere and the western hemisphere. Okay, so when we talk about the latitudes, we say that the temperature decreases as you go south or north of the earth. Okay, because at the equator we have that the temperatures are high because the equator is close to the sun, but as you move towards the north or towards the south, the temperature decreases. Okay, like it reduces because you're going further from the sun. And then when you look at longitudes, this is the side that faces the earth. We have the eastern part that is directly or faces the sun. That is why it is day. It has more light, therefore it is during the day. Because at the equator, we have that the temperatures are high because the equator is close to the sun. But as you move towards the north or towards the south, the temperature decreases. Okay, like it reduces because you're going further from the sun. And then when you look at longitudes, this is the side that faces the earth. We have the eastern part that is directly or faces the sun. That is why it is day. It has more light, therefore it is during the day, while the west is during the night because it does not receive as much light as from the east. Okay, but when the earth rotates or around its own axis and then the sun appears to be on the western side, the western side then will be receive more light and it will become daytime, while the eastern side or the eastern hemisphere will be darker because it will not receive light from the sun, so it will be at night. Okay, so that is basically about the latitudes and longitudes. And then the last thing I'm going to add, the latitudes is divided into 5 components. So there are 5 major latitudes. We have the equator, the Tropic of Cancer, the Tropic of Capricorn, the Antarctic, and the Arctic. Okay, so the equator, which is 0 degrees, Tropic of Cancer, which is 23.5 degrees north, the Arctic Circle, which is 66.5 degrees north, and then on the southern side, we have, rather let's say the southern hemisphere, we have the Tropic of Capricorn, which is 23.5 degrees north or south, sorry, and the Antarctic Circle, which is 66.5 degrees south. Okay, so yeah, let me give you a brief recap in case you did not understand. So we have the longitudes and the latitudes. The longitudes are imaginary lines running from the east to the west, and it lies between the northern hemisphere and the southern hemisphere. Okay, and then we've said that there are 5 major latitudes. We have the equator, we have the Tropic of Cancer, Tropic of Capricorn, the Antarctic Circle, and the Arctic Circle. Okay, and then we have said that as you go to the north or to the south, the temperature changes because at the equator there is more heat or the temperature is high, but as you go north or south from the equator, the temperature decreases. Okay, and then we've looked at the longitudes. The longitudes are imaginary lines running from north to south. Okay, it is located between the eastern hemisphere and the western hemisphere. And then we say that at the eastern hemisphere, it is when it is close to the sun, it receives more light than the western hemisphere, therefore it becomes the day, while the western hemisphere becomes the night. But as the earth rotates and the sun appears to be close to the western hemisphere, then it will receive more light and it will become daytime, but the eastern hemisphere will become nighttime because it will not receive enough light. Okay, so from there we're going to look at the structure of the earth. So The structure of the earth consists of 3 different parts. We have the mantle, we have the core, and we have the crust. Okay, so we're going to look at the crust first of all. Okay, so the crust is divided into 2 parts. We have the continental part and we have the oceanic part. The continental part is where you and I live and consists of 25% of the Earth's total surface area, while the oceanic part consists of 75% of the total surface area of the Earth. Okay, so we say that it goes or it runs deeper 2,900 kilometers. Okay, we have seen the oceanic layer of the earth is very deep. Let's say the biggest ocean in the world is known as Mariana Trench, which is 5 kilometers deep. Okay, so as you go down the earth, it is so I was saying the oceanic part runs 5 kilometers deep in the earth crust, while the continental crust runs 30 kilometers deep in the earth crust, so making a total of 35 kilometers deep in the earth crust layer of the crust. Okay, so the crust is then divided in sub layers. We have the upper layer and the lower layer. The lower layer consists of a seema, which is silica and magnesium, while the upper layer consists of the Cl, silica and aluminium. Okay, yeah, so that is about the earth crust. And then we're going to look at the core. The core is divided into 2 parts, two parts, inner layer and outer layer. So the inner layer and outer layer consist of iron and nickel, but the inner layer mainly consists of iron, which is the heaviest metal, or the most dense property. Okay, so iron is solid in nature, so the inner part of the core is very heavy and very dense, and it is solid in nature, but the outer core is liquid in nature. That is why it forms the molten substance or the molten state. That is why the outer core is the molten part of the core. Okay, because it has the liquid properties. And then we have the mantle. The mantle is found between the outer core and the inner core. The boundary between the outer core and the mantle is known as the Gutenberg discontinuity, but the boundary between the mantle and the crust is known as Mohorovičić discontinuity. So this is basically the structure of the earth. We've said it consists of the mantle, the crust and the core. Okay, we say the crust is divided into 2 parts. We have the continental part and we have the oceanic part. The continental part, which consists 25% of the surface area, while the oceanic part consists of 75% of the surface area of the earth. Okay, so having looked at that, my dear students, I really ask you to revise, work hard. There are quizzes that I'm going to give you at the end of this lesson. I'm going to write them down. You make sure you do it. Practice more. And in case of any questions, please feel free to come to my office or contact me so that I can be able to make it clear to you. Okay, so I hope you have really enjoyed this lesson. Have a wonderful day and take care.